What if all the lightning on Earth struck the same place at once? It begins with a strange silence. The skies above the planet are choked with heavy storm clouds, thick and dark as molten steel. From the savannas of Africa to the skyscrapers of Manhattan, from the frozen tundra to tropical jungles, every weather system across the globe is holding its breath. The air is charged, not metaphorically, but literally. The static is so strong you can feel it in your teeth. Birds stop flying, animals freeze mid-step. Somewhere, a child's hair stands on end as if the earth itself were holding a secret too heavy to keep. Then it happens. From every cloud, every storm cell, every potential thunderhead across the world, bolts of lightning fire downward, not scattered, not random, but targeted, synchronized. Every single lightning strike on Earth, normally scattered across millions of square kilometers, all hitting one single point on the planet. But where? Let's say it's a remote field in Central Asia, far from any town or city, pure open land under an unlucky patch of sky. For a fraction of a second, that spot becomes the most energetic place on Earth. Normally, Earth gets about 1.4 billion lightning strikes per year, around 44 per second. But for the sake of this thought experiment, let's assume all of those strikes happen at once. That's 1.4 billion bolts of pure electrical fury, each carrying an average of 300 million volts and 30,000 amps. Multiply that by over a billion, and you're dealing with energies so vast they stop making sense in human terms. The bolt doesn't even look like lightning. It's more like a column of white-hot plasma the size of a mountain, slamming into the earth at the speed of light. The air around it doesn't burn, it vaporizes. Trees explode before the shockwave reaches them. Stones melt into lava. The soil turns to glass. Every molecule in the area is torn apart, reassembled, and then torn apart again. Within the first millisecond, the temperature exceeds that of the sun's surface. A deafening sonic boom ripples out in all directions, not once, but in an unrelenting roar, as if the sky is being torn in half. The electromagnetic pulse, EMP, is so strong it knocks out electronics globally. Satellites blink out, power grids fail, communication dies, aircraft plummet. For a few seconds, humanity is blind, deaf, and powerless. At ground zero, a crater has formed, deep, glowing, and molten. But this isn't like any crater we've ever seen. The intensity of the strike is so colossal that the crust of the Earth itself is damaged, not just the topsoil. We're talking tectonic scale. The energy might not quite match a full-blown asteroid impact, but it's enough to fracture rock for miles in every direction. But the heat is something else. The lightning's energy turns air into plasma and dirt into gas. A fireball rises, mushroom-shaped, eerily similar to a nuclear explosion but even more violent in some ways. The thermal pulse ignites everything in a 100-kilometer radius. Forests vanish in flame, grasslands combust, animals never even have time to run. And then comes the shockwave. Expanding outward at hundreds of kilometers per hour, the blast levels everything in its path. It's not just wind, it's pressure, raw, brutal, and unrelenting. Buildings far away collapse as if made of matchsticks. People are thrown through the air like dry leaves. Roads ripple like water under the force. Blast shatters hundreds of kilometers away. Global weather begins to react immediately. The sudden injection of energy into the atmosphere creates massive turbulence. Jet streams go wild. Unseasonal cyclones form. Rain starts falling in sheets, then stops, then begins again sideways. Lightning, real, natural lightning, returns, but it's chaotic now, uncontrolled, as if the Earth is confused about what just happened. And let's not forget the magnetosphere. That much electromagnetic energy in one point could disturb Earth's magnetic field, even if only temporarily. Compasses swing uselessly. Migrating animals lose their sense of direction. Some regions might experience auroras, not at the poles, but at the equator, ghostly lights dancing in the sky like nervous fingers tracing the edges of catastrophe. But the most terrifying consequence might come days or weeks later. The intense heating and sudden release of particles into the upper atmosphere might damage the ozone layer. A hole, localized but potent, could appear over the strike zone, letting in ultraviolet radiation at levels we've never measured. Skin burns faster, crops wither, DNA gets scrambled, life struggles to adapt to the invisible but lethal presence of too much sunlight. In the end, the strike zone is unrecognizable. Where once there was grass, or forest, or farmland, now there's only fused rock, glass, ash, and a silence so deep it feels wrong. The Earth will eventually recover, nature always does, but the scar will last for centuries. As for humanity? We'd survive, probably, but the world would never quite feel the same. Something ancient in our instincts would remember that day not as a storm, but as a message, a reminder that nature doesn't need to shout to show its power. Sometimes, it just focuses, and when it does, it strikes with the fury of a billion storms.